Hi there, welcome to this video on momentum. So here's the first equation we're going to use. P equals mv. P is momentum, m is mass, and you can probably guess that v is velocity. So what about the units? Well, if mass is measured in kilograms and velocity is measured in meters per second, then momentum has to be measured in kilograms meters per second. Now here's a definition. The property or tendency of a moving object to continue moving. So it's basically how much does something want to keep moving? How difficult is it to stop something? If something's very difficult to stop, then it has a lot of momentum. And what's going to make something difficult to stop? Well, if it's moving very fast or it has a very large mass, then it's going to be difficult to stop and it's going to have a high momentum. So let's use this equation. We've got a car with a mass of 1,200 kilograms. It's traveling at 80 meters per second. Calculate the momentum of the car. So we know the mass m is 12. We know the velocity v is 80. So we simply multiply those two together and we get 96,000 kilograms meters per second. Okay. Here's another equation. Now this is an equation that relates force with change in momentum and time. So the v here is the final velocity, and if you multiply this by mass, you get the final momentum. The u is the starting velocity, so this time m multiplied by u is going to give us the beginning, the initial momentum. And the final momentum minus the starting momentum is going to give us the overall change in momentum. And let's have that in words instead of symbols. There's the equation. Force is change in momentum divided by time. So let's look at a little example question. A car travelling at 20 meters per second collides with a wall and is brought to rest in 0.5 of a second. The mass of the car and the occupants is 1,000 kilograms. Calculate the average force on the car during the collision. Well, there's our equation, and it's very, very simple. All we need to do is feed all our numbers in. So the mass, it tells us, is 1,000 kilograms. Now v is 0. V is our final velocity. Now here's the only tricky part of this question. It says, and is brought to rest. If it's brought to rest, that means its final velocity is 0. Its initial velocity was 20 meters per second, and it took 0.5 seconds for this crash to happen. So you feed all those values into this little equation here. 1,000 multiplied by 0, anything multiplied by 0 is 0, minus 1,000 times 20, and this is what we get, and the final answer is minus 40,000 newtons. Now because this is a deceleration, the number comes out negative, but you don't need to do that negative sign. The answer is 40,000 newtons, or 40 kilonewtons. Okay, let's finish this PowerPoint by looking at conservation of momentum. So long as no external forces are acting on the objects involved, the total momentum stays the same in explosions and collisions. So when it says no external forces are acting on the object, it means anything else, and that includes friction. So we're operating in a friction-free environment here. So here we are, we've got one blue ball at 5 kilograms and it's going to travel at 10 meters per second, so it's going to have an overall momentum of 50 kilograms meters per second. Here it goes, 50 kilograms meters per second. Now it's going to collide with this red ball, which is the same mass, 5 kilos. And if this blue one comes to a dead stop and it's 0 meters per second, it loses all of its momentum. So it went from 50 down to 0. And if the momentum is conserved, then this red one has to pick up that 50 kilograms meters per second of momentum. So it's 5 kilograms. So what speed is it going to disappear off at? Well, to conserve that 50 kilograms meters per second, it's going to have to go at the same speed, 10 meters per second. And off it goes. Let's change things a little bit. Let's have a situation where we've got 5 kilogram ball again, 10 meters per second, and this time it collides with the red ball, but this time the red one is half the mass. We have to conserve the momentum. It has to be, this red ball has to go at 50 kilograms meters per second. That's the momentum it needs. So 2.5 kilos this time multiplied by what gives you 50 kilograms meters per second? Well, it's got to be 20, hasn't it? So we've halved the mass of the red ball, and in order to keep the momentum the same, to conserve that momentum, we have to double the velocity. So that's conservation of momentum. There it goes, 20 meters per second. So here we are. Here's a couple of questions to test a few of the concepts we've gone through. So if you pause the video now, have a go at these questions, then unpause it, and in a second the answers will flash up. Thank you for watching. you.